So here's the last three problems of the Chapter 8 practice test. So our first problem here is about work, and hopefully we remember from Math 4 or from physics that work is equal to force times distance traveled. And so in this case, we have 30 pounds acting at a 40-degree angle, moving the wagon 100 feet. And so our force is 30 pounds, but we're moving the wagon 100 feet horizontally. It says pulled horizontally by exerting that force. So what that means, if we think about the situation, is that some of my, oops, I was going to put my, here's my 30, here's my 40 degrees. Not all of my 30-pound force, pounds, is actually moving the wagon horizontally. Some of that is wasted force. So we have to figure out, well, how much force is actually going horizontally? What is that force component? Because that's the component of the force that actually matters. So what we need to do is just think about this as a triangle. I don't care about the vertical component of it. Here's my horizontal component. I don't care about the vertical. So x is going to be 30 times cosine of 40. And so that's going to give me an x of 22.981. So what that is, again, that's the number of pounds that are actually moving the wagon horizontally. The other, a little more than 7 pounds is actually not helpful in terms of moving the wagon horizontally. So my formula then, work is equal to force times distance, becomes 22.981 times 100, which is then 2,298.1 foot-pounds. And so part B is really just asking us to explain everything that I just said. So our explanation for part B is, well, work is only force times distance if the force and distance are in the same direction. So we can't multiply 30 times 100 unless the wagon was being moved at a 40-degree angle, say up a 40-degree ramp, in which case the motion and the force are in the same direction, and you can then just multiply those things together. Another kind of classic basic physics vectors problem is the force required to stop something from falling down or sliding down an incline. And so we've got, our classic Math 4, Kevin McAllister. So the first thing that the problem asks you to do is say, well, why is Kevin's answer incorrect? And Kevin's answer is 53 pounds. Well, it simply cannot take 53 pounds of force to stop a 45-pound girl from sliding down the ramp, because the total amount of force that she has at this time is 45 pounds. So that's it. So the first part is, Kevin, your force cannot be greater than 45. And then it wants us to modify the diagram. And so what this is all about, and if you remember, we did the problem in class where it was Mr. Ferreira taking Christmas lights off his roof in, March. And so what we said is we're thinking about, sorry, not straight lines here. The 45-pound force is like the hypotenuse, and then we're creating this triangle here, which is a right triangle. And you have a force that is pulling parallel to the slide, and then a force that is perpendicular to the slide. And it's the perpendicular force, it's the parallel force that we need to counteract, because that parallel force is what is pulling the girl down the slide. So the question originally is, what is the magnitude of the force that is required to keep her from sliding down the slide? So we're looking for this. How do I counteract that piece? So the problem doesn't actually ask me to solve it. It just says, show how he needs to modify his diagram. Done. And indicate what part of the diagram he should be solving for. Well, this part here. So we'll just say solve for that, Kev. Because again, that's the part, and it does say to explain our choice, what we have to counteract is the amount of force that's pulling her down the slide, which is parallel to the slide. The amount of force that's perpendicular to the slide, the other part of my diagram here, well, that's the part that's already helping her to not slide down. So that's not the part that I care about. I care about this part. All right, last question. Which of the following vectors are orthogonal to vector v? Two ways to think about orthogonal. One is that it creates a right angle, so you can kind of plot the given vector and then think about which of these would be perpendicular to that. Or we know that if two vectors are orthogonal, their dot product is 0. And I think for a problem like this, it's kind of useful to think about both of them at the same time. Like, okay, well, what would it be? Like, would it even make sense to be perpendicular in terms of slope? This one goes right 2, down 7. So would going right 7, up 2, would that be reasonable to be perpendicular? I think yes. You know, right 2, down 7 versus right 7, up 2. Yeah, I could see a right angle happening in there. And if you check the dot product, you're going to get 14 plus negative 14. So that is in fact 0. So A is yes. B, the dot product does not work out. C, it does. And when I say work out, I mean it equals 0. D is one that often causes people trouble. D is orthogonal, and people are like, well, wait, how does that fit the perpendicular piece of it? Well, it doesn't necessarily, but it does fit the dot product part of the definition. And so based on that, that is in fact orthogonal. These two don't work. So the perpendicular idea is really a visual way to think about it, but the dot product is actually the definition. So the 0 vector here, D, would be orthogonal to every vector. So that is part of the choice there as well. All right, that is it.